All right, let's balance a couple of equations. So lithium carbonate solution is mixed with ferrous nitrate. So we're going to assume these are both in solution. So I'm going to write out lithium carbonate. We need to remember that lithium is +1 and carbonate is -2. So I'm going to need 2 lithium carbonates. You need to remember that all lithium compounds are soluble. So we're going to put aqueous. And then we're going to mix it with ferrous nitrate. Ferrous is +2 and nitrate is, -1. So that's going to be FeNO3. That's nitrates -1, so we need 2 of them. And just as all lithium compounds are soluble, all nitrate compounds are soluble. Okay, now let's try to figure out what kind of reaction is this going to be. Is it going to be a composition reaction, decomposition, combustion, single replacement, or double replacement? Well, if you see we've got 2 ionic compounds, this is going to be double replacement. All right, so we're going to have the lithium go with the nitrate. Now lithium, I know there's 2 of them here, but lithium is +1 and nitrate is -1. So those go like that, and we'll deal with the 2 later. That's very important, but we'll deal with it in a minute. And then lastly, the iron, that's got a +2 charge, is going to go with the carbonate. So these 2 compounds, basically lithium and iron, change last names. What's important here, though, is to remember that iron 2 or ferrous carbonate is not soluble. So that's what makes this a reaction. If it weren't for that, this would be no reaction. Okay, let's balance it. So I've got 2 lithiums and 2 nitrates. I'm going to put a 2 in front. I've got 1 iron and 1 iron, 1 carbonate, 1 carbonate. So that's balanced and we have correct states. Now let's add calcium to water. Okay, so calcium is a metal. It's going to be a solid. It's always going to be a solid at room temperature. And then we're going to add it to water. Okay, now it's real important that we remember what kind of reaction this is. This is critical. And many students get confused. Is this going to be a combination reaction? It can't be double replacement, obviously not combustion or decomposition. So are these 2 things going to combine into one product? Or are these single replacement? Does the metal replace one of the hydrogens? Well, that's what happens. This is single replacement. This is a very often missed reaction. Now, if it were calcium oxide plus water, that would be decomposition. Know the difference. So what are we going to get? Well, calcium is going to replace one of those hydrogens. So let's replace that one. And we'll get calcium hydroxide. Again, make sure you know how to do this. Calcium is going to be +2, and so we're going to need 2 hydroxides. You also need to remember, now that we have water present, that it is aqueous. Write that a little better. Okay, so what's the other thing that forms? Well, it's going to be hydrogen. And hydrogen is diatomic, and it's hydrogen gas. Now you can see why this is so often missed. So we really need 2 hydrogens and 2 hydroxides, so we're going to put a 2 here. Now it's balanced. So again, make sure you know what happens when we mix a metal with water. This is an active metal, okay? Calcium is an active metal. And so it would be above hydrogen on the activity series. So that's something else you would have to consult. But calcium is going to replace hydrogen, and you get two products, so it's single replacement.